Hello, in this video I would briefly like to demonstrate how to extract data from a polar plot like this using the software WebPlotDigitizer. This is some example that some person sent me via email. He sent me this raster graphic in the JPEG format, which you can see has not the best quality and resolution, but fortunately this person also sent me a corresponding vector graphic file in Visio. As you can see, this has much better quality as it's a vector file. And so what I will do here to make the extraction more exact, I will make the line a little thinner, maybe go to 0.2 centimeters, and then export this as a PDF file with lossless compression. Just save it on my desktop as polarplot. And then go to this WebPlotDigitizer website, which is this one here, and check for this file. And here it is, so we can directly load it. And I will go to full screen mode and zoom in maybe a bit. And so then we can set up and add and calibrate some axes here, add calibration, and it's a polar diagram. So we want to have polar axis. And for the calibration, as you can see, we need to select the origin and then 2 points with a different radius and a different theta or phi angle. So, and there's some magnification glass here on top. So I will try to hit the origin as precise as possible. And then I will select this point here, which is maybe here, and a second point or third point somewhere here. And then you can see we need to give the radius and the angle of these corresponding points. And the y-axis here starts at -30 and ends at 10. But I assume that the origin is really at 0. So I say this is 10, this is 20. And then this would be 30 and 40 for the radius. And for the degrees, this is 0 degree, this is 60 degree. And it's clockwise because it's rotating like the clock. So we can calibrate. And then there's a color picker and it detects these 5 colors. And as we can see, this has 0.3% of occurrence. This has much less. So we will select this as the main color. And then we can set something as maybe 2 pixels of difference between points and run this. And you can see we get a number of 446 points, which should be enough to capture this diagram, to extract the data and to replot this diagram in a different software like MATLAB. For example, so here we can view the data, and as you can see, we get variables for R and theta. And interestingly, the R comes first and the theta comes second. And it's with a comma instead of a dot as a decimal separator, which is also quite uncommon. But anyhow, we can download this as a file with comma-separated values, CSV, and I will also call this polarplot CSV. And then open up this file in some editor like Notepad++. And to be able to import it in MATLAB, it would be a good idea to change the comma into a dot. So I will replace all the commas, and I'm not sure if the semicolon works. So I will also just change all the semicolons into spaces and save this file, and then switch over to MATLAB, which I've already opened up. And here is the file. And so we can say this file we want to load in some variable called rawdata. So here we have the polarplot CSV file. And as you can see, then we get these 446 rows and 2 columns. And the first thing, so if I plot the first 10 rows of the 2 columns, you can see we get R and theta or phi, the radius and the angle. And we want to flip over these columns. We want to interchange these columns. So we say raw data is raw data. We want to have all the rows, but we want to have the second column first and then the first column. So we want to interchange the two columns. And I will suppress the output with the semicolon. And now if we take a look at the first 10 rows again, we can see that, okay, we have interchanged them, right? Except for this, nothing changed. We have just flipped the two columns. And so now theta or phi, the angle is first and the radius is second, which is great. But we want to sort it according to the angles. So there is some command that is called sortrows. And so we will take our raw data, sort it, and put it back into the same matrix called raw data, and sort it. And if I take a look at the first 10 rows again, now you can see it's nicely sorted according to the angles, which is great. So now we can extract our data and say, okay, the angle theta, this is all the rows from the first column in this matrix, and our R is all the rows from the second column inside this matrix. And so now we could have a polar plot. But at first maybe it would be good to open up a figure, which opens up on the different monitors. So there's an empty figure. And so then it would be great to, because we want to have a polar plot, to add some polar axes. So I will save this in a variable called AX for the axis, and it's polar axis. And okay, there we have some axis thing. So as you can see, we already get some empty polar plot in our figure. Maybe I can snack in this figure somewhere here. Yeah, so now we can say, okay, inside these polar axes, we want to have a polar plot, and we want to have it with our theta angles and with all the corresponding radius angles. And interestingly, it says, okay, it's not polar, it's polar plot. I'm so sorry. Oh, yeah. And then, okay, interestingly, it does not work because this polar plot expects our angles to be in radians and not in degree. All our angles here are in degrees, so we need to convert them from degree into radians. We do this by dividing by 180 and multiplying with p. And now you can see, okay, this is already looking quite nice because this was our original diagram that we started with. And this already looks more or less similar. The difference is here the 0 is on the top, and here the 0 is pointing to the left, to the right. And so there is some command in MATLAB that or some property. There is the theta 0 location. This is how it's called. And we set this to be on top. So, okay, now the 0 is on top. We are getting closer. Problem is, this is as usual rotating counterclockwise, but this is rotating clockwise. So we also need to set the corresponding direction. And so there is another property here, this theta direction or theta direction. I'm not sure how to pronounce this. And so we can now change this to clockwise. And if we change it to clockwise, now it's rotating clockwise. And now you can see it's looking fairly similar to what we started with. And yeah, so this is a nice solution on how to extract data from a figure file like this. Get the data and replot it in a more sophisticated software like MATLAB. You can do some similar stuff, of course, also in Octave or in Python, maybe with Matplotlib. In Octave, I'm not sure if you can like rotate the polar plot and change the direction of the theta axis. I unfortunately don't have a license for Origin Pro, so I cannot do it there. I more rely on open software, but Octave cannot do this in this form. Another thing that I could recommend is to use the nice pgfplots package inside LaTeX to also nicely recreate such polar plot or figure there, also in a very good vector format, and then to be able to save it as a PDF file or to insert it into your documents, papers, publications.